Welcome to the Rethink Vertical podcast. On today's episode, I sat down for a follow-up conversation first started last year with Kraettli Epperson, who is CEO and founder of Vigilant Aerospace. So in case you missed the last episode, Vigilant Aerospace is the leading provider of detect and avoid and airspace management software for uncrewed aircraft systems. The company's product, Flight Horizon, is based on 2 NASA patents and uses data from multiple sources to display a real-time picture of the air traffic around a UAS and to provide automatic avoidance maneuvers to prevent collisions. The software is designed to meet industry technical standards, to provide automatic safety, and to allow UAS to fly safely beyond visual line of sight. In this episode, we dive a little deeper into detect and avoid methodologies, UTM concepts, as well as what airspace management might look like with scaled commercial UAS operations. I also asked Kraettli about some of the exciting projects they have on the horizon. We also chat about a recent partnership between Vigilant and Droneport Network as we continue to integrate airspace solutions to support commercial UAS operations in the future. I always come away from any conversation with Kraettli feeling a little more informed about the UAS and advanced air mobility space, and this conversation is no exception. So I hope you enjoy the episode. Welcome to the Rethink Vertical podcast, and joining me today, Kraettli Epperson, round 2, right, Kraettli? This is round 2. We met last year on the podcast. A lot going on with Vigilant and your Flight Horizon product, so be interested to hear more about that. Talk about some of the projects and partnerships that are key to kind of growing the industry. But welcome to the podcast.
Thanks, Craig. Very eager to be back here talking with you again for a second time, and for you and I to discuss some big developments and announcements that we've made over the last few months and things that are coming up. So eager to talk.
Yeah. So before we do that, I'm sure there's folks that are listening that didn't hear the first podcast. So would you mind just giving a quick overview of Vigilant and what you guys work on?
Sure. Yeah. So I'm the CEO and co-founder of Vigilant Aerospace. We're the leading provider of multi-sensor standards-based detect and avoid systems. So these are collision avoidance systems for drones, advanced air mobility like air taxis, and autonomous aircraft. So we specialize in writing the software that allows these aircraft to be aware of and to avoid encounters, conflicts, collisions with other aircraft. Is a really important function. So we started this software based on a couple of patents that we licensed from NASA. We've been working on this for several years, and so we have versions of this that run on the ground, and they connect to a variety of sensors. So we connect to transponder receivers to pick up the radio signals from aircraft. We connect to radars to detect aircraft that might not be transmitting anything. And we also connect to the autopilot on a drone or on an air taxi so that we're aware of the status of the drone all the time. And so we have both, as I said, ground-based ones. We also have onboard versions. We're currently developing a version for the Air Force, actually, for a new secret drone that the Air Force is working on. We were awarded that contract. We've done projects for the FAA directly. We do projects with NASA, and we do projects with multiple research institutions that are advancing the status, and increasingly with commercial organizations, which we're going to talk about during this discussion. But that's really what we focus on, is that standards compliant safety software that fills in a really important gap in the marketplace right now. As we like to say, there's really no autonomy without autonomous safety. You really need your aircraft to be able to be aware of those other aircraft around it to fly autonomously.
Right. So, the safety piece is key, and I think that's that's what the regulators are working through right now. It's like, hey, it's some really cool technology. How do we ensure its safety? How do we ensure the level of safety is the same or better than traditional aviation? And in some cases, it needs to be better, right? Because things are operating autonomously, close together in complex environments. So kind of thinking, along those lines, with Vigilant, with Flight Horizon, the product that you're talking about, that sort of software safety system. One of the key components, I think there's 2 key components, right? You've got your airspace management system, which is the bigger piece of it, but then the critical piece is that detect and avoid, right? DA is something we hear a lot in the industry now. It's a hot topic. A lot of folks use the acronym in different ways to mean different things. So I think it'd be really valuable for folks to understand, like, what is detect and avoid? What are the pieces of it? What pieces have we gotten figured out for the most part? What pieces are a little bit maybe under debate? And then where does the FAA or other ANSPs and regulators kind of sit on the level of detect and avoid needed to really think about full autonomy? What are you seeing?
Sure, yeah, absolutely. So when we use the word DAA or detect and avoid, we have a very specific meaning. We are focused on an end-to-end system that has a high degree of autonomy built in. So there are sometimes you'll see articles written talking about detect and avoid where the focus is on a sensor that's going to detect an aircraft that may be coming into conflict with your drone. And that can be an important part of a DAA system. Often that's a discussion about a radar, or it may be even a discussion about transponders. But the reality is that to have a full end-to-end DAA system, you really need to be able to not only detect the aircraft, but you need to be able to predict the trajectory of that aircraft and how it relates to the trajectory of your aircraft, the one that you're responsible for keeping safe, whether that's a small drone, medium-sized agriculture drone, or maybe even a much larger, air taxi or cargo aircraft. And then you have to be able to calculate, after you've determined that there's a potential conflict, what the appropriate avoidance maneuver is that you're responsible for taking. So those are all of the logical components that have to exist. And then the other thing to be aware of in a DAA system is that you have what are called cooperative aircraft. So these are aircraft that are broadcasting something, usually with what's called an ADS-B transponder. And that allows you to see that aircraft potentially a long ways away and pick that up. But then you'll also have aircraft that are not required to carry that transponder, and those you have to pick up another way. You have to detect them with a non-cooperative sensor, like a radar. There are other sensors out there, but radar is really considered a standard and widely used for this, all the way from small portable radars, which we use, up to slightly larger radars, which we also use, up to air traffic surveillance and terminal radars. All of the above are important ways to detect aircraft that are not broadcasting. And so when we think of detect and avoid, we really think it has to have all of these elements. It has to be able to detect cooperative aircraft, non-cooperative aircraft that are not broadcasting anything. It has to be able to do a prediction about where those aircraft are going to be and determine if that aircraft that's coming into your airspace is going to be too close to your drone, for example, based on what the rules are for where you're flying. And then finally, we have to calculate what we call a standards compliance avoidance maneuver. So we focus on ASTM F3442, which is one of the standards for small drones for detect and avoid processes. We also look at DO 365B, for example, which is an RTCA standard for larger aircraft for detect and avoid. And these are industry standards which are implemented through something called ACAS or ACAS-X, which is the collision avoidance algorithms that those standards define for you to be able to actually avoid that aircraft in a way that the FAA considers acceptable, right? That meets that technical standard.
Right.
So we knit all of those things together. That's really a lot of what we focus on, is making all of that work together efficiently so you get the data in from the sensors and then you can perform that maneuver in a timely way so you can stay safe all the time. So when we say DAA, we're talking about all of those parts.
Right, right. Yeah, and I think that's where some of the confusion comes in is, with that acronym kind of being thrown around in the industry for different reasons, and sometimes it's not even on purpose. Folks don't fully understand the whole process of detecting and avoiding, and I think that standards compliance piece is critical because it's not just about seeing something's out there; it's responding in a way that fits a requirement that really already exists. And so it's like, okay, well, we see a thing, we know what its speed, its trajectory is, what size it is, and there's a certain level of separation and movement that's required. It's not shut the operation down until the thing goes by necessarily, although that is a way to meet, a waiver requirement at some point. But if you're talking about operating an environment where aircraft all have to work within the same standard, that's the really hard piece, right, to build in a DA
Yeah.
system. So with all, okay, we've kind of gotten some background on that.
Now thinking about the airspace management piece, right? We're going to talk a little bit more about that and some of the projects that we're working on between Droneport Network and Vigilant. When you think about airspace management, where does DA fit into that, and how does airspace management need that piece in order to operate effectively? Because we hear a lot of folks talking about airspace management systems, and sometimes that means a little bit different. What does it mean to you guys?
So as a part of our system, we provide a display of the air traffic that the various sensors that have been deployed are detecting and tracking, because those are precursors to being able to do the detect and avoid process I just described. And so by having that, all of those integrated sensors and a display that's tracking that air traffic over some distance, right? Depending on what sensors you've decided to use, you can be aware of the aircraft that are flying around, both crewed aircraft and uncrewed aircraft, various types of drones. You can become aware of that. You can put it on a big screen. You can watch it. You can begin to form protocols, rules, have a cadence around that process of when aircraft are going to fly, where they're going to fly, aircraft that you know about, aircraft that enter the airspace that you didn't know about, but you're detecting and tracking for safety purposes. And so when we talk about airspace management, we're talking about using the sensors that you've invested in, using the process
Mhm.
that you've invested in and are building up to provide a greater overall situational awareness for everybody who might be involved in your operation, in your facility, in your drone port, in your small airport, and putting that on a big screen so that it can be shared. And that is all of that is a precursor to being able to do that standards compliant detect and avoid process. And of course, that's mostly everything I've described is when you're operating on the ground, usually with a small drone, as the drones or multiple drones that you're operating. And so when we talk about airspace management, it's the ability to take all of that and present it to the responsible people who are managing potentially lots of pilots, lots of remote pilots, lots of aircraft, and being aware of what the picture looks like in a really organized, moving map, a very visually understandable way.
Right. Yeah, I want to dig into the drone port concept a little bit more. We can talk about shared infrastructure a little bit as well, but I do want to quickly touch on UTM. And I know this is something that you guys think a lot about. You're kind of thinking about how it's developed, sort of real time and down the road. I know we don't have any certified UTM systems. We have a lot of people working on it and talking about it. FAA is not signed off on any of these systems. There's pilot projects going on in Texas, trying to figure out how to operate together, drone operators operating together. Can you help walk us through, like, sometimes DA and UTM kind of get stuck together in the same conversation, and they do play roles in each other's environment. We want to talk a little bit about what is UTM, and what's needed to actually make it successful and work.
Sure. Yeah. I mean, UTM and detect and avoid are related parallel technologies. They're related parallel protocols. They don't do the same thing, but they can work hand in hand, right? So UTM, or uncrewed traffic management, is a set of protocols, rules, standards, ways for companies and operators to communicate with each other, and protocols around how you're going to communicate with each other about where and when you're going to fly, right? So it's first and foremost a reservation system, but it's also a communication system with a set of predefined servers and services that allow different remote pilots to communicate with each other to say, I'm going to fly from this point to this point at this time. And if something happens in the middle of that, the system can warn me about that. I can be aware of contingencies, like another emergency aircraft that has to fly through. And I can use that system to coordinate a large number of aircraft. That's the idea. It's kind of like a cell phone network. So when NASA conceived this idea, the idea is that you have multiple vendors potentially that are providing UTM systems, and they can all interact and interoperate with each other without the end user needing to know. Like when you pick up your cell phone, you don't have to know what network your friend is on. You don't have to know what tower they're connected to. All of those systems are interconnected using standards and protocols, and so you can interact with your friend without knowing anything about their cell phone or the tower or the network that they're on. And the same idea holds with UTM. that you can fly your drone and fly without conflict, by having reservations and having communication up to a network that's connected, right? So that's the UTM side. Detect and avoid, and UTM typically is going to deliver some form of strategic deconfliction, meaning we agree that we are not going to fly at the same place at the same time, right? And so as
Right.
long as everybody's participating, that provides deconfliction, right? You're not going to fly at the same time in the same place as somebody else. And that's typically called strategic deconfliction. Detect and avoid is focused primarily on tactical deconfliction. There's a conflict right now. These aircraft we didn't know they were going to be there, right? We knew we were going to be here, but we didn't know this aircraft was going to approach us. We don't know, and we don't have to know why they're approaching us. We just know that we're responsible for maintaining a safe distance, right? And
Right.
so detect and avoid is the process of allowing you to have enough airspace awareness using a mix of sensors, and then a process you follow to create your avoidance maneuver that keeps you safe, right? And that keeps the other aircraft safe. And so it can go hand in hand with UTM in that detect and avoid systems can feed that information about tactical deconfliction and air traffic that's flying around in the same airspace that a UTM system might be operating. And the remote pilots might be using a UTM system to allow them to stay safe. And it provides an additional level of safety. We think of safety as kind of a multi-layered process. And so UTM, particularly for coordination between multiple drone operators, is important. But the ability to also know about air traffic that's nearby that the UTM system would not be aware of, and to feed that data in either to individual pilots or to the UTM system overall is an important additional safety factor that DAA provides to a UTM system. Does that make sense? I mean,
Right.
it's a
Yeah,
lot.
no, it does. It does. And it is a lot. And I was going to say that one of the things that, you know, kind of came to mind, and I've heard lots of folks talk about UTM lots of different times. But one of the things that just kind of popped in my mind there is that in order for a UTM, like a real UTM system, strategic deconfliction to actually work, all all known participants really have to participate in the system, right? And that includes traditional aircraft need to participate because they're all kind of fall. Because one of the things we hear is like with drone delivery, it's like, okay, we've got like these 3 drone delivery companies all participating in a UTM system, but none of the aircraft are participating. It's like, well, how does that work, right? They can separate from each other, but they need some other way to separate from, and maybe, we know that they're using ADS-B in the mode CVL, and so we know they're using that as sort of their, maybe their the way to tactically deconflict. So we'll kind of see how those exemptions and projects play out over time. But I also think about this like paralleling traditional aviation and kind of the way it came about, right? So you had aircraft came about. It's the big sky theory, right? Not a lot of airplanes, a lot of airspace, and so folks could fly around and not worry about running each other. Over time, there were more and more aircraft, and then you introduced air traffic control, right? They're really the DAA of traditional aviation, and they made sure, okay, we've got quite a few airplanes in this one particular airspace, or they all want to land. We need to make sure somebody's watching out, other than the pilots, to make sure they don't run into each other. Some sort of eyes, seeing a radar. And then once it got so complex that even air traffic control was like, okay, we can make sure they're separated, but it's not super efficient. If you want them all lined up and you want them all at the right time, we need some sort of like traffic management system to come in and provide that other layer. So that there are different layers of safety. And I kind of see DA and UTM playing that same role. It's like, if you don't have a lot of drones, there's no point in having UTM because you get to use standard DA and they can miss each other. But the whole point of making this industry work is you need a lot of drones to make the business model work. So folks are really pushing UTM from the start. Am I right or wrong on that? Like, how do you see it?
Yeah, I mean, all of those topics are in tremendous amount of discussion right now. So figuring out how traditional aviation is going to interact with systems like UTM is an important question that I know the FAA is wrestling with, and it's one of the big questions that will gradually be answered as the FAA releases new notices of public rulemaking particularly around the Beyond Visual Line of Sight Aviation Rulemaking Committee that I served on a couple of years ago, and that the FAA is drafting new rules, sometimes called Part 108, for new Beyond Visual Line of Sight rules for drones. We know that part of what those rules are going to begin to try to address is how these different types of aircraft are going to be expected to interact. And of course, you're right that with the big sky theory, the idea is, well, there are not very many aircraft, and it's a really big sky, and so you just need to manage them in points of high density and manage them in controlled airspace. And of course, with drones, you potentially have many, many more aircraft. And it's one of the reasons UTM, for example, is very interesting and useful, is you're not going to want to have an air traffic controller paying attention to
Right.
every delivery drone delivering something to somebody's backyard. That's not realistic,
Right.
and that's why UTM is emerging as a solution, because you want a high degree of autonomy, you want very low cost. Like, how much cost do you want to add to your toothpaste delivery, right? It's probably not going to be a person's time staring at that drone, making sure that everything's safe to deliver to your backyard. And so the question becomes, how do you do that? And so UTM is obviously one of the ways to do that. And then how these systems will interact with other aircraft that might be flying at low altitude is an important question that I know the FAA and others are wrestling with right now.
Yeah. So I want to move into the drone port conversation a little bit, just because this one's appropriate for both of us. When we as a company started thinking about what is a drone port, what does it really mean? I mean, we really think about shared infrastructure, right? Both physical and digital infrastructure, and the fact that there's a high cost in that, right? Hardware and infrastructure, and even software, it's not cheap, and so kind of expecting each individual company to kind of bring their own level of infrastructure to every project is just a non-starter, right? It's not scalable, and it's not going to work. So one of the things we started thinking about is how do we find other strategies to get that infrastructure in place, share it among users, make it cost more cost friendly, because we really didn't see another way for the industry to scale. And so as we thought about this concept of a drone port, these geographic areas where these systems are set up, whether it's airspace management, setting up the radar systems, remote ID sensors, and other sensors and data that you're going to need to detect aircraft, communication C2, all of that needs to be in place. That's one of the things we've been thinking about. And some of the folks watching probably saw that a few weeks ago we announced a strategic partnership between Vigilant and Drone Port Network to use Flight Horizon as sort of our airspace management system as we start to develop some of these drone port projects. So we're excited about that, and we think that one of the key reasons that was important for us is because Vigilant has been one of those companies that has been kind of on the forefront of this technology from the beginning, been very involved in sort of getting a feel for where the FAA needs and wants to go, and being involved in those conversations. So I don't know, anything you want to share on that sort of potential partnership and kind of how you see that playing out from a drone port perspective, shared infrastructure perspective?
Yeah. Oh, absolutely. Yeah. So, I mean, as I said earlier, just as sort of at airports, you don't bring your own tower, you don't bring your own controller, you don't bring your own aircraft typically, although you can. Those are all shared infrastructure, and they're a mix of public and private partnerships to make that airport work and make it affordable so that you can buy a ticket and get on an airplane. Same with a cell phone network, is your sharing infrastructure. And so we're really excited about this partnership with the Drone Port Network because of the expertise that you all bring in terms of public-private partnership development, the ability to help with that infrastructure development and rollout that's absolutely necessary for the growth of this industry, both with drones, different types of larger UAS, and then ultimately advanced air mobility. These things are absolutely critical. And so Drone Port Network is a pioneer in helping facilities, cities, communities figure out how to put those partnerships together and how to get a system put in place to make all of this work. And so, it's, for some people, it is tech-driven economic development. They know that they want their community to be at the forefront and to be enabling these technologies early on. I know in Tulsa, that's part of the vision, and in many other cities counties and states where there is this idea that you really don't want to be left behind, that aviation is changing as an industry quite rapidly. And so, Craig, we're excited to be involved with you and with the Droneport Network because of all that subject matter expertise that you all bring about these partnerships. And of course, we're the technology provider, right? We are
Right.
in the business of making this seamless, installing systems where we've thought about what's required, reducing the what we like to say the science experiment part of it, so that you can have a system
Right.
in which there's already been a significant amount of NASA research, FAA research, increasingly military research about how to build these systems safely and make them effective. Well, we're benefiting as a company from that public investment to bring this really important technology to market. And of course, DPN is a great way to get that out for people to use.
Right. Yeah, no, I appreciate that. And I think that, what we're also seeing is, um, you know, as this industry emerges, there's all these different companies, Vigilant being one, that had to become like mini system integrators, right? Because you've got to own the whole stack because it doesn't exist, and so you've got to demonstrate your product. And so one of the things that's really important for us is bringing in those companies that have been doing these pilot projects, sort of like, you know, in the weeds, doing the hard work, and then at some point we need to define these projects that can go after customers, like real commercial customers, real potential revenue. So those are the types of projects that we're excited about. So kind of piggybacking on that, we're excited about this future first drone port that we'll be partnering with you guys on, bringing Flight Horizon into Skyway 36, the drone port that we're managing there just outside of Tulsa, setting up the airspace management system, making it available for potential customers for both testing and eventually commercial operations once we get down that road, and having that system kind of set up and available for folks to see and use and feel and understand how it works. And I think that'll be a really cool project to work on.
Yeah, we're excited about it. We see this area as having very, very high potential. The area is really investing in both the Osage Nation and Skyway 36 and Tulsa generally, and the state of Oklahoma are all really focused on enabling this next generation of aviation. And there are several nodes and center points throughout Oklahoma and the nation where this technology, infrastructure, public-private partnership is all concentrating. And Skyway 36 is obviously one of those places where that nexus is occurring. So we're extremely excited to be involved there and to see all the types of flights and operations that are going to start occurring there very soon.
Right. Yeah, folks are getting excited about the possibility of having access to the system, and I should mention too that it'll probably play a key role in operations within the greater Skyway range and some of those nodes and operations. We'll see how that plays out over time. I did want to give you a couple minutes. I know you got a lot of exciting projects. You guys are redlining. You got lots of things going on. Any specific projects that you want to provide updates on? And a lot has happened since we last chatted in the previous year. So just wanted to open the floor to you if there's things you wanted to cover.
Sure. Well, I'll just mention a few things. So
Mm-hmm.
we are increasingly working on projects that involve, for example, remote ID. We have, as we've previously announced, a partnership with Pierce Aerospace. They are a manufacturer and developer of an advanced remote ID system. They have products both for the civilian market and the military market. And our partnership with them allows us to pull in very high quality, potentially long range remote ID data, which can be extremely useful for drone safety and for safe operation of drones in, for example, urban areas. And so we've begun bringing that in and cooperating with them. So there's some exciting projects that we'll probably be announcing about that. We're also bringing in an increasing number of radars. So our system already integrates with a wide range of radars. We're using larger radars to provide much longer range for some of our customers. I think with Skyway 36, that'll also be the case, that there'll be much longer range radars available to enable much more advanced operations, to be able to go inspect an entire wind farm, inspect an entire ranch or farming area, multiple agricultural sites, and do it quickly all at once. So there's a lot of that kind of work going on, a lot of industrial support going on with drones that we're working on enabling. And of course, we're working with drone manufacturers. So some of those, these are mostly larger drones, some of them are military drones. We have our Flight Horizon Pilot product, which is our onboard product, which takes all these capabilities of both cooperative and non-cooperative detection and brings it into a centralized unit that is that safety brain that is providing those avoidance maneuvers. And so we're rolling that out multiple places. And I know we're gonna be announcing some things. We've already announced this project that we won with the Air Force. But we also have some other manufacturers that we've been working with on things like air taxis. And so those will be really important over the coming, 24 months probably, to actually see some of those aircraft fly and begin to have these systems on board to provide that safety assurance. So a lot of ground-based stuff, some airborne stuff as well. So.
Right. Very cool. Very cool. Well, I know you got a lot going on. I appreciate you carving out 30 minutes for us to have a chat and sort of make some of those announcements, which is really cool. A lot of work to be done yet. I think we'll see some big changes over the next 12 to 18 months as we see a draft of Part 108 come out for public comment. That should be an interesting process. And we'll see how that goes. And at least folks will know what's out there and what we're looking at. So I think that will be valuable. But yeah, appreciate the time.
We're looking forward
to yeah, right. I know everyone is. But Kraettli, thanks. And yeah, let's keep moving forward.
All right. Thanks, Greg.
If you'd like to be a part of the UAS Cluster Initiative community and get access to more of our content, check us out at www.uascluster.com.